area between the curve and the y-axis. The area bounded by the curve x is equal to g of y, the y-axis and the lines y is equal to c and y is equal to d is given by the area would be equal to the integral from c to d of x dy. Now, the diagram to the left illustrates such an area. This is, so there's a curve, and the curve is x, g of y. So it is a function, the curve is a function of y. So the area is bounded by the curve, the lines y is equal to c, y is equal to d, and the y-axis. So this line here is the y-axis. And that area S is given by the formula, or is given by the integral from c to d of x dy. Let's have a look at an example. This is example 12. In example 12, we're asked to find the area of the shaded region. So this is an example. You have a curve that is bounded by, you have an area that is bounded by a curve. The lines y is equal to 8 and the line y is equal to 1. Now, this area, the shaded area, would be equal to the integral from 1 to 8 of x dy. All right, so we need to get x as a function of y. We have y as a function of x. Now we need to get x as a function of y. So y is equal to x cubed. Now, if I find the cube root of both sides, I'm going to have y raised to the 1/3 power, which is the same as saying finding the cube root, is equal to x cubed raised to the 1/3 power. So what I did is I found the cube root of both sides. So therefore, on the right hand side, I'm going to have x is equal to y to the 3rd power. And so the area, the shaded area, would be equal to the integral from 1 to 8 of x, which is y raised to the 1/3 power dy. All right, so this, so let's just integrate. If we integrate, we're going to raise the power by 1. So this becomes y to the 4/3. 1/3 plus 1 is the same as saying 1/3 plus 3/3, which is 4/3. And of course, sorry, before we get there, we have to also divide by the new power, which is 4/3. And this is within the limits 1 to 8. Dividing by 4/3 is the same as multiply by 3/4. I'm going to pull the 3/4 out. So I have 3/4. And then I have what? Y raised to the 4/3. And this is 1 to 8. From y equal 1 to y is equal to 8. So now I'm going to put in where y is 8. So I have 3/4. If y is 8, I'm going to have 8 raised to the 4/3 power minus, replace y with 1 to the 4/3 power. All right, so 4/3 is a fractional index. And when you have a fractional index, the denominator is the root and the numerator is the power. Now, the cube root of 8 is 2, and then 2 raised to the power 4 is 16. So this is 3/4, and this is 16. 8 to the 4/3 power is 16. Minus 1 raised to any power is still 1. So my final answer is the shaded area is equal to 3/4 multiplied by 15, which is 45/4 square units. All right, so we're asked to find the shaded region between the curve, the y-axis, and x is equal to 1 and x is equal to 8, which we just did. Let's have a look at another example. All right, in this example, we're asked to find the area of the shaded region in the diagram. And of course, the shaded region in the diagram is a region that is bounded by a curve, and the lines x is equal to 1 and x is equal to 3. So this area, the shaded area would be equal to the integral from 1 to 3 of x dy. All right, and so this would be equal to the integral from 1 to 3 of y minus 4 square plus 2, and we're integrating the entire thing with respect to y. So that's a linear factor. So to integrate, my answer is going to be equal to y minus 4 raised to the third power. So we increase the power by 1 and then divide by the new power, which is 3, plus 2y. If we integrate 2 with respect to y, you get 2y. And this is within the limits from 1 to 3. So the next thing we're going to do is that we're going to replace y with 3, and then we're going to minus whatever we get. With 1, we replace y with 1. So we're going to end up with 3, because we're replacing y with 3. 3 minus 4 over 3 raised to the third power plus 2 times 3 minus what we would get if we replace y with 1. So that is 1 minus 4 over 3 plus raised to the third power plus 2 times 1. So if I take away 4 from 3, I get minus 1. Minus 1 to the third power is minus 1. So this is minus 1/3 plus 2 times 3, which is 6, minus, we have 1 minus 4 is minus 3, minus 3 cubed is minus 27 over 3 plus 2 times 1, which is 2. All right, so we're going to end up with 5 and 2/3 here. 5 and 2/3. If I take away 1/3 from 6, I get 5 and 2/3 minus, and then we have inside the bracket minus 9 plus 2. And so of course this becomes 5 over 5 and 2/3. 5 and 2/3 minus 7. Because 9 minus 9 plus 2 is minus 7. So we end up with 5 and 2/3. A negative times a negative is a positive, plus 7. So our final answer is 12 and 2/3. And this is square units. And so the area bounded by the curve, the y-axis, the lines y is equal to 1 and y is equal to 3, that area is 12 and 2/3 square unit. Let's have a look at another example. All right, example 14, and this is our final example. We're asked to find the area of the shaded region in the diagram. So in the diagram, we have a curve that is bounded by the lines y is equal to 1, y is equal to 4, and the y-axis. In such a situation, the area or the shaded area would be equal to the integral from 1 to 4 of x dy. We have x in terms of y. Now we need y in terms of x. We have y is equal to 2 x squared, we'll divide both sides by 2. We're going to have x squared is equal to y over 2. The opposite of square is square root. So x would be equal to the square root of y over 2, which is the same as saying the square root of y over the square root of 2, which is the same as saying root 2 over 2 y raised to the half power. So the square root of y is the same as saying y raised to the half power. And so the area now would be equal to the integral from 1 to 4, the integral from 1 to 4 of x, which is root 2 over 2 y raised to the half power. And of course, I'm integrating with respect to y. I'm going to pull the root 2 over 2 out front. So now I have root 2 over 2, the integral from 1 to 4 of y raised to the half power. So far, so good. dy. If I integrate y to the half, I'm going to get, this becomes root 2 over 2. Increase the power by 1, I'm going to get y to the 3 over 2. Divide by the new power 3 over 2. And then my limits are from 1 to 4. Now, dividing by 3 over 2 is the same as multiply by 2 over 3. So what I have is root 2 over 2 multiplied by 2 over 3. And in bracket, I'm going to have y to the 3 over 2, 4, 1. Now, next, I'm going to replace y with 4. Then I'm going to replace y with 1. So the 2 here cancels the 2 here. So now I have root 2 over 3. And in bracket, I'm going to have 4 raised to the 3 over 2 power minus 1 raised to the 3 over 2 power. Now, a fractional index 3 over 2 means that the root is 2 and the power is 3. The square root of 4 is 2 and 2 raised to the third power is 8. So of course what I have is root 2 over 3, and in bracket this is 8, minus 1 raised to any power is 1. So what I have here is root 2 over 3 multiplied by 7. So my final answer is 7 root 2 over 3 square units. And so the area bounded by the y-axis in this scenario, bounded by the y-axis, the curve y is equal to 2x squared, the lines y is equal to 1 and y is equal to 4. That shaded area there will work out to be 7 root 2 over 3 square units.